Hola.
Hello.
All right, let's graph something that we pretty much already know, a real easy one. Y equals x minus 1. You guys think that's linear or non-linear? Looks like something we've done. This one is, guys, trust me, is linear. And graph it. And it should make a... What x values do we usually choose? That makes sense. You don't have to choose those 4 values. It makes things easier. Okay, let's do that. Equals 0 minus 1, which is negative 1. Okay, let's put 1 in for x. Y equals 1. Take our calculator for that. 0. Y equals 2 minus 1. How much is 2 minus 1, guys?
1.
1. Y equals... What's negative 1 and take away 1? Negative 2.
Should we draw a line on it?
Draw your line after you graph your points. 0, negative 1. 1, 0, 2. Okay? They should line up. 0, negative 1. Down on the y-axis there. 1, 0. It's on the x-axis, actually. 2, 1. Up in quadrant 1. And then negative 1, negative 2 down in quadrant 3. How many people, their 4 points lined up?
I did.
Yeah, right? It's linear. So, use your straight edge or just free-handed, I don't care. It's a pretty good straight line right there. That thing is linear. Okay? All right, answer some questions. Is the graph linear?
Yes.
Yes.
Why?
It goes to the origin.
That's
But
making
it's a
non
straight
It's a
line.
positive slope.
No,
If it's
It
a
doesn't
straight
do
line.
the origin.
because it makes a straight line.
Or it doesn't
It
go
actually
to-
doesn't go through the origin. Okay?
on
So you
a
would say,
positive slope.
is the graph linear? Yes.
Yes.
Because it makes a straight line.
Question.
That's why it's linear, because it makes a straight line. Okay? Do you guys think you'd be able to tell if it wasn't linear?
Yes.
What would happen with the points if it was not a linear?
Did
Would
we
make
throw
a
it out of
circle
whack?
or be curved.
It wouldn't make a straight line. It wouldn't line up. Let's watch what happens here. All right. Harrison, question. Go ahead.
Does it matter if you use 1, 2, 3, 4?
No. I would like to encourage you to use a negative value just to see what happens in the negative when you go left of the y-axis.
But do you have to?
If it's non-linear, like the next one, yes. So you might as well get in the habit with the linear ones. Okay? All right.
Negative 1, negative 2, negative 3.
The next graph is y equals x squared minus 1. We're going to find out if that's linear or non-linear. I've already hinted at it. What do you guys think?
Not linear.
Does anybody know how a smart kid could tell it's not linear just by looking at the equation? What's
Yes.
different?
Exponent.
Guys, there's an exponent. What's on that x?
2.
It's x squared. Okay? So, everybody jot this down. X is squared. And believe it or not, guys, that makes it non-linear. When we do a table of values, they're not going to line up. But they do make a shape that you guys are all going to know after today. Cool shape.
A square?
That would be really cool. Let's
Circle?
not make it square. Close. All right, here we go.
Hexagon.
Semicircle.
Hexagon.
We'll see. Be patient. I don't know how excited about this. All right, what's the smartest x value to always choose in a table?
7.
Not 7.
0.
0. Always
Negative
start
1.
with 0.
Negative 2.
Okay?
1. 2.
I'm going to do 1. Okay? And I'm going to do 2, and then I'm going to stop right there. Because then let's do those first. Watch what happens. Then we'll do some negative values and see what happens. So everybody take 0 and plug it in there. You might need your calculators here. Or I think most of you guys are pretty smart. You can do it without a calculator. Here we go. Y will be 0 squared minus 1.
Negative 1. Negative 1. Negative 1. Negative 1.
How much does that make, guys?
Negative 1.
Negative 1. 0 squared is 0. Minus 1 is negative 1. So I know the point 0, negative 1 is on the graph. Let's try 1. Y equals 1 squared minus 1. Okay.
1.
What's 1 squared? 1 or 2?
2.
Think about it. What's 1 squared?
1.
1. Because it means 1 squared means 1 times 1, which is still 1. The knucklehead kid says it's 2. Don't say it's 2. So 1 minus 1 is 0. So I know that the point 2, 0 is on there. Okay? Now, watch what
It's
happens
1,
when you
0.
put 2 in.
It's 1, 0.
Oh, did I put it the wrong way?
Yes.
I put 2, 0. Sorry, I was looking at the next value. Thank you. It is 1, 0. Thank you. All right, let's watch what happens when you put 2 in. Okay? 2 squared minus 1. See if you can do that in your head.
4 minus 1.
Ange, how much is that?
It's 3.
I think it's 3. 2 squared is how much, people?
4.
4 minus 1 is
2.
3. 2 comma 3. Okay?
You're both.
Now, what would be the next? Let's try a negative value. Let's see what happens. Let's try negative 1.
Yay.
Okay, something weird's going to happen. When we substitute a negative number in for x, what should we always put around it that'll help us?
Parentheses.
Make sure you put parentheses around negative numbers. Even with positive numbers, you can put parentheses around it, make more sense, but definitely with negative numbers. So negative 1 with parentheses around it, squared outside the parentheses, and then we're going to subtract 1 from that. Okay? Don't blurt it out. Raise your hand if you think you know what negative 1 with little parentheses around it squared is. Raise your hand when you got it. Negative 1 parentheses squared. Phoebes. 1. Why is it positive 1, Phoebes?
Because 2 negatives is positive.
When you multiply 2 negatives, you get a positive. Great explanation. So negative 1 squared, guys, is positive 1. And then Phoebes, subtract 1 from it. 0. Ruh-roh. We got the same y value twice. Look at that. We got 0 when x was 1, and then we got 0 when x is negative 1. Something weird's going to happen here.
Pentagon.
Okay? Negative 1, 0 is a point. Everybody put in negative 2. Be real careful and watch what happens. Negative 2. Y equals parentheses, the quantity of negative 2 squared, and then subtract 1 from that.
It's a pentagon.
It's not a pentagon. Quit saying weird mathematical terms.
What it is.
Equilateral.
It's a curve.
Curve. That's an intelligent comment. Who knows what negative 2 with parentheses around it squared is? Teddy?
Well, the answer's 3.
Okay, but there's a negative 2 squared is 4, right? Minus 1 is 3. And negative 2, guys, squared is positive 4, because negative 2 times negative 2 makes positive 4. Subtract 1, we get a 3. So I know the point negative 2, 3 is in there. Okay? Now, important word, I think you guys all know the definition of this word, but, okay, put a little star. Do you guys know what the word symmetrical means?
Yeah.
Equal
Yeah.
on both sides.
Okay? With these graphs, you're going to look for something, when x is squared, you're going to look for something symmetrical.
It's a pentagon.
Man, stop.
It is.
It's not a pentagon.
Yes, it is.
It's a U.
Do you use straight lines to pentagon?
All right, let's graph the points and watch what happens. 0, negative 1. We know that down there on the y-axis. The point 1, 0, right there on the x-axis. 2, 3. Oh, look at it, guys. They don't line up. It's like Billy said, it's a curve. It does make a curve. Negative 1, 0. Ooh, does that point look symmetrical
Yeah.
from the point to the right of it? And watch what happens with the negative 2, 3. It's symmetrical. Guys, this shape is going to be symmetrical around the y-axis. Okay? Put another big old star over here. I'll show you. X, when x is squared, it makes a, Billy called it a U. Billy, do you know the correct word? What the U shape is called? And if you don't, you just say I don't know it.
I don't know.
Does anybody know what it's called? It's called a parabola.
Parabola.
Sounds like a terrible disease.
I've heard that word before.
Parabola. Do not call it a parabola. Okay? You go to high school and you're algebra 1 teacher and you call it a parabola, I'll get emails and bad things will happen. So anyways, x squared makes a parabola. Everybody say parabola. Parabola. And it is a, draw a parabola. It's a U-shaped figure that kind of goes, the sides go up forever. It ain't linear. It's a curve, but the correct name of it is a parabola. Harrison.
So, but if you connect the lines like straight lines, it's a pentagon.
Right. Yeah, but you don't connect them because when you connect the lines, you're saying that the points in between them count. They don't. The line, it goes up forever. So now here's how you sketch this. You make a curve. It doesn't have to be perfect. Just do your best job. Kind of start. This is called the vertex of it, the bottom here, and kind of just draw a curve up, and then do it on both sides. And then does everybody see why I said it was symmetrical?
Yeah.
It's the same on the left and the right, and that's a parabola. So whenever x is squared, it ain't linear. It makes a U-shaped parabola. Okay? So if x is squared, what happens if y is squared instead of x? What if y is squared? Guess what happens? It's a sideways parabola. If y is squared. Then what's the next logical question?
If it's the all negatives, then
What if everything's squared?
What if both of them are squared? What if x
Upside
is
down.
squared
Upside down parabola.
and y is squared?
Upside down.
No. That's when it makes a circle. Or it might, depending on what numbers they put with, I put x squared twice there. I meant x and y squared. So x and y squared, it makes a parabola, or it makes a circle, or it might make what they call an ellipse. You guys know what an ellipse is?
an oval.
Yeah, it looks like an egg, kind of. Okay. So if x and y are squared, we got circles, and you guys are going to do this in algebra 2, a lot of this. Okay. If y is squared, it's a sideways parabola, and we're going to do a lot with x squared. That just makes it up and down. Does it always go up?
No.
What do you think would happen if make it go down?
All negative numbers.
If negative x squared, if the coefficient of x squared is negative, it actually flips upside down and goes downward. It's a downward U. Upside down U.
It's a frowny.
Frowny face instead of a smiley face. So, just things you guys are going to... All right, back to the question. Is this thing linear?
No,
Why not?
because it makes the curve.
Because it makes a curve. Very good. No. Not, or say not linear, not a straight line.
It's a parabola.
Not a straight line. What were you going to say, Ange?
It's a parabola.
It's a parabola.
Parabola.
All right, so I think you might have one of those on there. We're actually got the next section, 4.8, is all about, they call them quadratics as well. Quadratics and parabolas. All right, you guys are doing great. Let's get through the next couple pages. If you don't have a graph, you guys, believe it or not, know how to decide if something's linear or not. All right, let's fill in some words here. Linear equations are graphs that have straight lines. Linear, got the word line in it, means that it's a straight line. So if it's linear, it's straight. This is because there is a constant rate of change. That whole, from now on, guys, we're going to call it croc. So we don't have to write out or say the words constant rate of change all the time. Croc. Between any 2 points on the graph, okay, nonlinear functions are functions whose rates of change are not constant. They do not have a croc. Okay? Therefore, their graphs are not straight lines. Okay. No constant rate of change, not straight. Constant rate of change makes a straight line. I think this is what your homework's going to be like. Determine whether each table represents linear or nonlinear. Okay, and then you got to explain. Basically, guys, all you're going to do is find your slope. Okay, and you got to check every single point between all the points. All right, and we jot down over here. What variable, guys, goes up top with slope? X or Y?
X.
Oh my gosh!
Y.
I can't believe we have this on
B.
tape. Harrison, don't talk anymore. I'll get duct tape for you soon. Too much blurting out. You just say random things. Guys, on slope, what variable goes up top? Y. Okay? And remember, if you remember, we called it delta Y over delta X. Delta means the word change. It can mean the word change too. So the change in Y over the change in X. If you're given a table, this is where we made those little arrows. Okay, and we're going to find the change from one point to the next. Okay? And we're going to put y over x, the change in y over the change in x. How much does y change to go from 0 to 9? How much changes that? 9, thank you. Come on, guys, a little enthusiasm today. Over, how much does x change to go from 1 to 4? 3. Okay? Goes up 3. All right, what's 9 divided by 3? 3. The slope or the constant rate of change between the first 2 points is 3. We got to find out if it's always 3. Okay, we got to keep going. What's the change from 9 to 27? Grab your calculators or do it in your head, one of the two. Trace? 18. Over. Trace, what's the change from 4 to 10?
6.
Trace, guess what 18 divided by 6 is? 3. Shazam. Are we good to go, or go ahead?
Can't you just do y1 minus y2?
That's kind of what I'm doing.
Okay.
So you can just
Go ahead.
Can you just do that?
Yeah. You can totally do that. I think it's more work. Because are you going to do 9 minus 27, or are you going to do 27 minus 9?
I just did 0 minus 9, and then 1 minus 4, and I got 3.
Right. Okay. But you got to do that for every set of numbers. You got to do that like 1, 2, 3, 4 times. But I think when they give us the table, it's easier to just see the difference from one to the next. But you can do it. Yeah, you can do it that way. Guys, what's the difference between 27 to 36? 9. Over. What's the difference between 10 to 13?
3.
What's 9 divided by 3? 3. 36 to 45.
9.
Over.
3.
3 is how much?
3.
All right, 9. It's 3. Is the slope the same throughout this entire problem?
Yes.
Yes. Is this linear or nonlinear?
Linear.
Why?
That's what it says.
No. We don't know if it makes a straight line.
It can't.
What's the new word?
Bro.
Guys, that's how you're going to answer things now. There is a constant rate of change. It's always changing by 3. Okay? There was one kid in first period that raised their hand and said, what if I went from the first point all the way to the last point? But the change is going to be different. What if I go from here to there? Watch this. 0 to 45, what's the change?
45.
Over.
45 divided by 16.
1 to 16.
16.
No, it's not
15.
16.
15.
You got to subtract them. It's kind of what Tara said. Subtract them, so it's 15.
3.
What's 45 divided by 15?
9 over 3.
Always got to be the same. 45 divided by 15 is 3. So, you got to find the slope between all the points. If it's constant, it's linear because there's a constant rate of change. Try the next one and watch what happens. Do the arrows and find the rate of change. What's the slope between the first point and the second point?
2.
Not 2. It's 2 over
2.
2 over 2, which reduces all the way down to what? 1. The slope between point 1, the first set of values, and the second set of values is 1. Does everybody agree with that?
Yeah.
Okay, do the second to the third one and watch what happens. It's what number over what number?
3 over 2.
Harrison, get your calculator out. 2 to 6 is not a change of 3.
2 over 4.
And why are you doing x over y?
4 over 2. Oh,
You've got to do y over x. So it's 4 over 2. What's 4 divided by 2? 2. We've got 2 different slopes. Guess what that means about this information?
It's not linear.
It's not linear. You can stop. After you find one of them that's not true, that doesn't work, you can stop. It's not linear. Reason.
Not croc.
Not croc. Or you can say no croc. No constant rate of change. Because the change is the constant rate of change is 1, then it goes to 2. I bet it does something else. Okay? All right. Numero 5. Use the table below to determine whether or not the number of revolutions. You guys know what a revolution is? A turn. Everybody put your little finger up in the air. This is a revolution. And start at the top and go 1 revolution. That means start at the top and end up at the top. Do 2 revolutions. 1, 2. That's a revolution. Okay? Determine whether the number of revolutions per hour of a second hand on the clock is a linear function of the number of hours that pass. So we're talking about. You guys ever seen the old school clocks that got the hands on them? Yeah. Okay. You don't see many more. We're saying that does the second hand is that linear with the number of hours that go by? All right. Here we go. Everybody find the constant rate of change. Do y over x. Remember, hours will be x. The first.
It's linear.
Why is it linear?
Because it increases by 1 and 60.
60. How about 60 over 1? Is it always 60 over 1?
Yes.
Look at it. Is it? Look, it's always. It's got a constant rate of change. Okay. So this one would be linear. And then, what would the reason be, people? Drop. Okay. That's what you're doing tonight for your homework.
Really?
Using a table, finding out if the slope, the constant rate of change, is always the same. If it is, it's linear. If it's not linear. All right, last page. You guys are doing great. Ruh-roh. What about those numbers in that table?
We put them in.
Yeah, there's no numbers. You guys are going to have to, for some problems tonight, you're going to have to make up your own table. Okay, but we can do this. All right, a square has a side length of s inches. Okay, we don't know the exact length of the side, but they're going to say it's side s inches. Do you guys know a square? You guys, what's true about a square?
All sides are the same.
There's
What's
4
the length?
sides.
It's 4 sides, and they're all the same. Very good.
So it's going to be
4 sides, and they're all the same. Guess what the length of each side is?
S.
S. Everybody draw a square where all the sides are S long. It doesn't have to be perfect. Boom, 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 boom. S, 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 S. Done. I beat all you guys.
No, I already.
Oh, I lost a mate. One person I want to lose to. Just kidding me. All right. A square has a side length of S inches. The perimeter of the square is a function of its side length. So the perimeter is a function of the side length. How do we find the perimeter of a square? What do we do to find the perimeter of it? Go ahead, Harrison.
Length times width times height.
That's what they always say. That's not even the kind of figure we're dealing with.
Length
It's
times
not
height.
length
Wow.
times width is
Oh
area.
my god.
Okay? Guys, everybody get it through your thick skulls now. Area, we're going to multiply.
Perimeter is adding more.
How do we find the perimeter?
Add them all up.
Side plus side plus side plus side.
Okay? They're all like terms because they're all the same.
S
So,
times.
let's write that at the top. P, standing for the perimeter, equals? Guys, what's the perimeter of that square?
S times S times S.
Why are you multiplying?
S plus S plus S. Plus S.
It's not, well, I'm going to write it over here. They're all the same, they're like terms. We can add them together. What's S plus S plus S plus S? It's not S to the 4th power. Because we put the number first.
4S.
Guys, perimeter is 4 times the length of any one side. 4S. So there's the formula. You're going to have to come up with that on your own. Okay? What should we do here? We got to make a table. Okay, in the notes here, guys, we made the table for you. In your homework, you're going to have to make your own little table. Your tables do not have to be perfectly straight. You could totally make a table, guys, like this. There's a table. Okay? And if you want to do it up and down instead of long ways, that's fine too. Anyways, make a table. All right, here we go. Which one's the independent variable? Which one's the dependent variable? Which one's the x? Which one's the y? You guys know? Okay. The side length is the independent variable. and the perimeter is the dependent variable. Basically, the side length is x and the perimeter is y, or you could do s and p like we did up there. Okay. What would be a smart side length to use as our first side length for that square?
1.
0. You cannot have a square that's side length is 0. You wouldn't have a square then.
1,
Right, let's choose 1. What's the perimeter?
2, oh, 1,
4.
What's
4.
the perimeter?
4,
4. When s is 1, the perimeter is 4. What's the next side length we should probably use?
2,
2. What's the perimeter?
8,
8. 3. 12. 4. 16.
5, 20.
5, 20. Should we use a negative value here?
No.
No, you cannot have a perimeter. You can't have a square with a side length of negative units long. Doesn't make sense. Okay. All right, everybody find the slope for the rate of change.
4/1.
Okay. 4/1. Is this linear or nonlinear, guys?
Linear.
Why?
Because cross.
Cross.
All right. Is the check for the rate? Is it constant? Yes. So therefore, the function is linear, and the reason is croc. The slope, the constant rate of change is always 4. Okay. Go ahead, Matthew.
If we did put yes for is a constant, why would we have to put croc again?
I'm just writing things down.
Just cause.
Just writing things down. All right. Now, next problem, we're going to talk about a cube. What's the difference between a square and a cube?
Cube has sides, faces, edges.
Right, guys, a cube is all of a sudden we're talking 3 dimensions. A square is perfectly flat. A square is perfectly flat. There's no height on a square. Okay, but a cube, all of a sudden, we're talking about 3 dimensions here. All right, has a side length of n of s inches. Can you guys draw a cube?
Yes.
Okay, I'm gonna try. Here's how I draw a cube. I draw a square, and then from the corners I go back and to the right. And then I dash the ones I think might be in the back. That's a pretty good cube there. Angie.
I have to leave.
Okay, check the website. Homework's on the website. All right, the length of all the sides are s. So I'm going to throw an s here for my length, my width, and my height. Because now it's 3-dimensional. Okay? Do you guys know what's the formula for the volume of that thing? What do you guys do to find the volume of the cube? S to the 3rd power. Because it'd actually be s, length times width times height. But they're all the same variable, so I can just put an exponent of 3 on there. So it's volume equals s cubed. Okay? What do we do again? We make a table. The volume of the cube is represented by the expression s to the 3rd power. The volume of the cube is a function of the side length. Does this situation represent a linear or nonlinear function? All right, let's set up our table. What's the input? What's the independent variable? The side length or the volume? Side length. And then our volume is our dependent variable. It depends on the side length. Basically, that's our x and our y, or in this case, it might be s and v. Okay. What's a good side length to start with? 1. I'm going to start with 1. Okay. What's 1 cubed?
6.
Oh my
3.
God.
Oh my god.
Pedal cow.
I thought because there were 6 sides on the cube.
But look, we're using the there are 6 sides on a cube, but we're using the formula. What's 1 to the 3rd power?
3.
1.
Is it 1 or 3, people? 1. Okay. What's the next good value to use for s? 2. See if we can cube 2. I always had to do them on my fingers. I would put 3 little fingers up in the air. We're going to cube 2. 2 times 2 is how much?
4.
Times 2?
8.
8. All always did them on my fingers. So side length is 2, the volume is actually 8. Continue with that pattern. Next side length. Let's do 3 cubed. Do them on your fingers. What's 3 times 3?
9.
Times 3.
27.
You're going to see the volume's going to get very big quickly. Let's do 4. Can you guys cube 4 on your fingers? That's hard. What's 4 times 4?
16.
Times 4.
64.
64. It gets big fast. We're even going to go all the way up to 5. 5, you should start. I read 65 because I was thinking 5. It's actually 64. Okay. 5 is one you should know. What's 5 cubed? You know what 5 times 5?
25.
Times 5? 125. Okay.
Disappointing.
Constant rate of change. From point 1 to point 2, it's 7 over 1. But watch what happens to the next one. It's 19 over 1. Is this linear?
And croc.
Is it linear?
No.
They call them non. You can write nonlinear or not linear. I don't care which one. No croc. Okay? So, I think that's what you guys are doing basically for your homework tonight. Nonlinear, no croc.